Good evening, everyone. Welcome to Competitive Triple V. Today, I'm going to start Chemistry 10th class Cbse part. So, the chapter name is Acids, Bases, and Salts. So, today we are going to discuss about what is meant by acid, how we are going to get acids and bases, and physical properties and chemical properties of acids. We will start. So, now, first of all, when it comes to the acids, everybody, whoever joining in the class, please come into the live chat and text messages, as well as we will continue the topic. So now, let us start with the topic. So when it comes to the acid, bases, and salts, first of all, we supposed to know what is meant by acid. So here HCl is given. So this substance is going to dissolve in water. So when any acid means the substance which is going to dissolve in water and gives H3O plus ions. How this will be forming? First, initially if we take acid, this can be dissociated into H plus Cl minus. And then this H plus is going to react with water molecule. So this H plus is going to react with the water molecule. Then it gives H3O plus. So here formation of positively charged particle in the hydrolysis means in the aqueous solution form, the substance is going to produce H3O plus, then it will be known as a acid. So now acid is going to react with the water and gives the positively charged particle, that will be known as an ion, and those will be known as acids. So now we will go for next slide. So next topic is about the indicators. In the 10th class chapter, whenever we will see, next topic is about the indicators. When it comes to the indicators, what will be there? So when it comes to the indicators, what is meant by the indicator? First of all, indicator is a substance so here indicator is a substance which shows the color change property in the given unknown sample. Indicator is the substance which shows the color change property in given unknown sample. Those will be known as the indicators. So when it comes to the indicators, generally these are going to show the color change properties in acid or base. So then when it comes to the indicators, we have three types. So those are, first one is about natural indicators which are extracted from the nature, and next another one is the olfactory indicators. At the last we have the synthetic indicators. So when it comes to the natural indicators, in that we have the litmus, red cabbage, turmeric, China rose, and hydrangeas. So then original color is purple, red, yellow, light green, blue. So regarding this, we will see the pictures, then we will get the clarity. See here, when it comes to the litmus, original color is purple. So from where we discover, we extracting these, those were lichens. From lichens, we are extracting the litmus. So here we have two types of litmus papers. One is a red litmus This is a red litmus. Another one is a blue litmus. So when it comes to the red litmus, it is giving the color change as a blue in case of basic solutions. This color is blue. So litmus paper originally purple, which is extracted from the lichens, and then this red litmus can be turned to blue in case of basic solution. And when it comes to the blue litmus in acids turns to red color. So this is about the natural indicator litmus paper. And next, second one is when it comes to the turmeric. At home we will use haldi is known as a turmeric. So generally its color is yellow. So original color is yellow. Then if we added lemon here, this picture is showing it will represents the acid. So we added turmeric indicator to the acid. It is giving dark yellow color. Turmeric indicator gives dark yellow color with the acids. And here we are applying lime is nothing but base. So what is the color here we are getting is reddish brown color. Reddish brown color for the turmeric indicator with the base solution. This is about the turmeric indicator. So next we will go for the next one. So next we have the hydrangea. So this is about the hydrangea. Original color is blue. So in acids it will be blue, and when it comes to the bases it is giving pink color. So next, see here what we completed: turmeric completed, litmus completed, hydrangea completed. So next, when it comes to the red cabbage leaves, red cabbage leaves, original color is, see here, red cabbage leaves, original color is red color. In acidic medium also giving the red color. But when it comes to the basic medium, it is giving the green color. And next we have the chain arrows. Original color is light pink. So here we will see light pink color. In acids giving the pink color. In bases giving the green color. Okay. So now here if we see, baking soda is a basic substance. That's why blue color. And here purple color as it is no change. And when it comes to the vinegar, it is giving the pink color. So now we will go for synthetic indicators. When it comes to the synthetic indicators here, synthetic indicators, if you see, we have two are there. We have two, those are methyl orange and phenolphthalein indicator. So when it comes to the methyl orange, original color is orange and phenolphthalein indicator is colorless. So in acid medium it is giving the red color, in basic medium it is giving the yellow color. So here when it comes to the phenolphthalein indicator, in the acidic medium colorless, in the basic medium it is giving the pink color. So now let us see. So regarding these also changes. So here when it comes to the methyl orange, earlier what I said, red color. Sorry, it's supposed to, we have to take as an orange color. Accurate color is orange. This is orange color. If you have any doubts, please text a message beta, then I'll give you reply. See here. So this is originally methyl orange, color is orange. When it comes to the phenolphthalein, what is the color we are seeing here? It is colorless. White color is nothing but it is colorless. So when it comes to the acids, so here acid, In acid, what is the color we saw? This is the red color. When methyl orange is used with the acids, we are getting the red color. In bases, we are getting yellow color. And when it comes to the phenolphthalein indicator, it is a colorless solution, and meanwhile in acids it gives no effect, means no change, colorless only. And but when it comes to the bases, we are seeing color turns to the pink color. So that's why phenolphthalein indicator will be called as a basic indicator. And when it comes to the methyl orange, it is giving the color change. So that's why it will be called as a acidic indicator. Acidic indicator. Methyl orange will be called as a acidic indicator. So now we will go for the olfactory indicators. When it comes to the olfactory indicators, these are totally different from synthetic indicators as well as natural indicators. But when it comes to the olfactory indicators, these will functions based upon the smell. Okay, the principle behind olfactory indicator is smell detection. So here, whenever we are taking olfactory indicators, we have the examples as onion extract, vanilla extract and clove oil. So when it comes to the onion extract, we used to see smell detection, and when it comes to the bases, it will be destroyed. Vanilla extract also in the acids gives a smell detection, and in bases smell will be destroyed. And clove oil in acids gives the smell detection, in bases it will be destroyed. So here I would like to say one thing. So when we are discussing whatever the olfactory indicators we are using, those are applied on the acids and smell is going to be changed. So here which one is going to play the key role to change the smell? Only olfactory indicators. Because of this olfactory indicators, we are adding to the acidic medium containing acids, then only the smell is going to be detected. So in basic media, if we are adding, there is no effect on the bases. So that's why we are not seeing any smell. Okay. So because of that, which principle behind the olfactory indicators is smell detection, and meanwhile, because of these indicators, means olfactory indicators, giving the smell in the acids, not in the bases. Okay. So now we will go for, so now I completed explanation about indicators. In that we discussed about the natural indicators, synthetic indicators as well as the olfactory indicator. So now I am going to discuss about the universal indicators. Here the name is given universal. What is the meaning of universal? Hello sir. So here we will continue, and here universal indicator. When it comes to the universal indicator, universal, in that name only we have. So here matter belongs to any substance. So here any substance which is belongs to the matter. So here when it comes to our chapter, we used to say either acid or base or salt, whatever it may be, the substance. In each and every condition, we are seeing the different colors. So then, here what is meant by universal indicator? So, the universal indicator means mixture of all indicators, mixture of all indicators which shows color change property, which shows color change property in the given unknown sample. The substance which shows the color change property in the given unknown sample, those will be known as a universal indicators. See here, when we see generally 0 to 6.9. Here the acids, the pH value, the H plus ions concentration supposed to be 0 to 6.9. This frequency of the values will be considered as a acidic. See here. Here at this point 7 is starting. So before 1 gap is there. Till that means we have the units of 0 to 6.9. In between these ranges, we used to see or we used to get different colors. Then those all will be comes under acidic. And when it comes to the 7, here we are getting the dark green color. It will belongs to the neutral. So, and meanwhile, and here what will be 7.1 to 14 units. Here we are getting the different frequencies, color changes. So, universal indicator is the indicator which is a having mixture of all indicators and showing the color change property in the given unknown sample. Hello beta. So here we are going to see different colors with the different pH ranges. Then these will be known as a universal indicators. In acids we are getting red to yellow. And when it comes to the salt, we used to see it's supposed to be neutral. Not only salt. Sometimes we used to see acidic salts and basic salts. Oh, please. Welcome to the channel, beta. Whatever, if you have any doubts, you can text a message. I will give you reply. Okay, I will explain those things. So now, when it comes to the neutral pH, here we are supposed to see dark color neutral. It is only for the neutral substances. So here not only salts, sometimes other substances also comes like H2. It is not a neutral, sorry, it is not a salt, even though it will be having the pH of neutral, 7. So here, when it comes to the substances, when it comes to the salts, generally we used to see acidic salts and basic salts and alkaline. So in that case, it will be differs. Okay. So now, let us go for the next slide. So here, this is about the universal indicator. Now I am going to discuss about the pH scale. So before going to discuss about the pH scale, so here what will happen? So in pH, so what is the use of pH? pH scale, it is also one of the indicator. So in that what will happen is, we used to measure H plus ions concentration. H plus ions concentration we used to measure in the pH scale. So who is the scientist given this? This is given by Sorensen. Sorensen is the scientist, introduced pH scale. Here P is nothing but power concentration, and it is derived from the German word, that is the meaning power concentration is nothing but proton jet. Because of that reason only we used to write as a P, and by using this we are measuring the H plus ions, that's why it is called as a pH. And the concentration of H plus ions are going to measured by using the scale which is having the units of 0 to 14. That's why it is calling as a pH scale. So by using this pH scale, we supposed to measure either the given substances, acid, base or salt. So whenever we are getting that, so we usually get that 0 to 14 units. Then how we got this 0 to 14 units? Because of ionic product of water. So here generally if we take the water, it can be dissociated into H plus ions and OH minus ions. Okay. So H plus ions concentration usually we used to say that 10 power minus 7. And when it comes to the OH minus ions, we used to say 10 power minus 7. So totally how much we are getting? 10 plus 10 power minus 14. So here we are getting the 14 concentration terms. Because of that only in the pH scale we used to get 0 to 14 units. So then ionic product of water, concentration terms of water. So here ratio of the products H plus and dissociated ions. This is known as dissociated ions. H plus and OH minus are nothing but dissociated ions concentration to the compound concentration. Then we used to get the ionic product of water. So here, if it will comes to this, ionic product of water is equals to dissociated ions. So in this way, we used to get the 40 units in the pH scale. So whenever we are taking universal indicator and pH scale, so in both the cases, we used to see that pH units is 0 to 6.9. Here, we used to say acids and 7.1 from here. From here to 14 units, we used to say that bases. So here, how it will be distinguished? So here, we have the value of 10.5. Till that, we used to call it as a weak bases. Why they are given as alkali? What is the meaning of alkali? Water soluble. Alkali meaning is water soluble. So here, weak means partially soluble. When it comes to the strong, completely soluble. Partially soluble, completely soluble. That's why we are saying weak and strong. Alkali meaning is the substance which is going to dissolve in water or which is going to soluble in water. That meaning is known as a alkali. So partially dissolving in water, that's why these will be called as a weak bases. From here to here, called as a weak bases. From here to here, these are going to completely dissolve in water. That's why these will be known as a strong alkalis or strong bases. According to our NCERT textbook, if we see sodium hydroxide and potassium hydroxide, only these two are the substances given as a strong bases. Remaining all bases will be given as a weak bases. And when it comes to the strong acids, we usually see HCl, H2SO4 and H3PO4 as a strong acids. So they have the pH value of 0 to 3.5, and meanwhile these also completely soluble in water and produces more H plus ions. But when it comes to 3.5 to 6.9, in between this, we used to say that these are the weak acids. Why saying weak acids? Partially ionized and produces less H plus ions. Because of that reason, 3.5 to 6.9. In between that pH, acids will be called as a weak acids. Okay, so now, next we will go for pH scale units. Here you can able to see clearly. So strong acids 0 to 3.5 up to here means red color we used to see. And when it comes to 4, here we used to see orange color, and 5 yellow color, here pale green color. 6 means here dark green color, it represents neutral. And 8 to 10.5 up to here, we used to see blue color. And 10.5 to 14, here we used to see violet color or else purple color. These are the variation of colors we used to see in the acids, bases and salts. So here when it comes to the pH scale, it is like a universal indicator. So here power by measuring by using the H plus ions concentration, in the unknown sample, we can able to decide based on the color change with respect to the H plus ions concentration. We used to see different colors on the given unknown sample. So based on that, we can able to say that the compound is either acid, base or salt. So here, when it comes to the H plus ions concentration and with respect to the color here given C1s. So here 10 power 0 means here pH will be 0. In that case, the color will be red. Color is taken as red. So next, when it comes to the 10 power minus 1, just a minute, I will show you here. When it comes to the 10 power minus 1, the pH we supposed to take as POH plus pH. So 10 power minus 1 plus 10 power minus 30. So here 14 minus overall P power concentration of water is 14. Okay. So ionic product of water we supposed to take. This value is 14. But when it comes to the H plus ions concentration and OH minus ions concentration together if we consider. So here we are getting the pH as a 10 power minus 1. H plus ions concentration is 10 power minus 1. So then this minus 1 plus of minus 30. So sorry. Just a minute. I will give the clarity here. This 14 minus H plus ions concentration we supposed to do. So for that what we supposed to take? 10 power minus 1 is given out of this. So here remaining is OH minus ions concentration we supposed to take 30. So that unit will be subtracted, then we will get as a 1. So in that way we used to find out pH value, and then in that way we are getting 1. Okay, 14 minus this minus 1. Sorry, this 13 minus 30. So reverse we have to take. So here what we are supposed to remember is pH is inversely proportional to the H plus ions concentration and inversely proportional to the, just a minute. So now I'm right. pH is inversely proportional to the H plus ions concentration and inversely proportional to the acidity. Means suppose pH for us, suppose the given, if pH is given as 6, then its H plus ions concentration will be more pH. Here 6 is nothing but more pH. Then automatically H plus ions concentration will be 14 minus 6 we supposed to. Then how much we are getting? 10 power minus 7. 10 power minus 7 is nothing but here what we supposed to say? It will be weak. Sorry, 10 power 8. It will be considered as a weak acid. So next, then, so here if we see H plus ions concentration is less, and when compared to the pH, then it will be known as a strong acid. When compared to the pH, OH minus ions, sorry, H plus ions concentration, the value whatever we are taking here, it is more, then it will be weak acid. So in that way, pH is inversely proportional to the H plus ions and inversely proportional to the acidity. By using this, we can able to identify whether the given substance is having comes under strong or weak acid. Along with that, when comes to the basis, we will take that pH is directly proportional to the OH minus ions concentration as well as directly proportional to the basicity. Means when comes to the basis, suppose we have the value as pH is given as a 10. So 14 minus 10 we supposed to take. So 14 minus 10 if we do, what we will get? 4 units. So 4 units it is responsible for the OH minus ions concentration, not for the H plus ions concentration. So that's why automatically here whenever pH is more for the basis, automatically the OH minus ions concentration was, sorry, just a minute, OH minus ions concentration will be more. Okay, in that way we can able to identify the given sample is either acid or base. So next, role of the pH in our daily life. So here, first of all, if we take the human blood. So human blood and tears and saliva, they have the pH range of 7 to 7.8. 7 to 7.8. So this is a neutral pH. In that pH, everybody, human being can be served. And for second application, if we go for the second application, what is given? For gardening and farming. Basically, crops will sustain in the neutral pH, sometimes acidic soil pH also. So what will be the neutral pH? Neutral pH is 7 and acidic pH is 6.5. It is not entirely acidic but slightly acidic. So in that case, this will not be suitable for the normal growth of the plants. Then what we supposed to do? If acidic pH is generally, we need neutral pH. But here they given the acidic soil. So acidic soil means we supposed to neutralize by adding the base. So then what we supposed to add? So either calcium oxide or calcium hydroxide or calcium carbonate. So all these comes under bases or is basic salts. Whenever we are applying this, the acidic pH will be neutralized. So in that way, we used to get the neutralization for the soil, and then automatically plants growth we can able to see. So next, when it comes to the HCl production in the stomach. So here, generally morning to evening we are eating the food. That is going to be digested in the stomach because of HCl. So it is having mild pH when it comes to the stomach. So here, whenever it is going to release our whatever the food we are taking, that is going to be digested. So but here we have two cases. One is the hyperacidity. What is the meaning of hyperacidity? Increase the amount of acid during the indigestion. Means we are taking increase in the amount of acid during the indigestion. What is it called as? It is called as a fasting condition. Okay. So when it comes to this indigestion, due to increase the amount of acid, they are saying. So we are staying with the empty stomach. That is known as a fasting condition. So whenever we are in the fasting condition, here indigestion occurs. In that case also acid reflux. So that's why we used to feel burning sensation. So how can we relieve that pain? To relieve that excess acid, we have to intake antacid, which will suppress, neutralize the acid. Excess acid, those will be known as antacids, such as magnesium hydroxide or mild base that is to say sodium hydrogen carbonate we can take. Okay, and another condition is that just now I said about the fasting condition. What about another condition? Another condition is over intake of food. So sometimes it is over intake of food. If the food is your favorite, so you used to eat more in quantity. So in that case, we used to say that over intake of food. In that case, what happens? Food will be more to digest. Food quantity is more, and acid will be whatever daily secreted, that quantity only acid will be secreted. So acid is less. So insufficient oxygen is there for the digestion of the food. So in that case also we used to say that it is acidity only. So in that case we supposed to take vinegar or else lemon juice. This will digest the food, and by the neutralization procedure, either base By taking the base means here already excess acid is there. That will be suppressed by the antacids. Antacid is nothing but the substance which will be neutralize the excess acid. Those are known as a antacid. And when comes to the bases, when comes to the over intake of food, here food is more. Food quantity what supposed to be digest is more. But when comes to acid, it is less. So in that case, we supposed to take vinegar and lemon juice. And next, when comes to the pH inside the mouth, generally before taking the food, the pH of the mouth is basic. But whenever we are taking the food, after taking the food, pH is dropping down to the acidic. So it leads to the tooth decay. How it will be happens? So when it comes to the tooth, actually we have the calcium phosphate as a one of the product. In the tooth enamel, we have one of the product calcium phosphate. It is going to react with the acid which is earlier pH of the mouth is before taking the food is basic. But after taking the food, or after meal, it turned to the acidic. So whenever it is turned to the acidic, so here automatically this acid is going to react with tooth enamel which is containing basic salt. Then here salt is formed, that is insoluble calcium acetate is formed along with the phosphoric acid. So pH is dropping down. Okay, because of that reason tooth decay we used to see. What is the meaning of tooth decay here? We used to see cavities and reduced calcium levels. Okay, that is known as a tooth decay. So these are the applications of pH. Other than this, we will see few more. So next, insects are going to protect themselves by releasing the acids and bases. So such as bees, if we take honey bees, these are going to release the methanoic acid, and wasp sting releases alkaline solution. Means here alkaline solution given. What is the meaning of alkaline solution here? We used to say that base solution. So then, when it comes to the ant bite gives what? When ant bites us, we will feel irritation because of methanoic acid. Methanoic acid is released. Because of that reason only we used to get the burning sensation. And next, when it comes to the nettle sting. So it is also going to release methanoic acid. And then in 3 cases, honeybee and ant bite and nettle sting releases the methanoic acid. Then we are going to feel the pain. So then what is the remedy? What is the solution for this to relieve from the pain? So here we supposed to take bases. What we supposed to suggest? Mild base, that is to say baking soda. Mild base, that is to say baking soda. That is NaHCO3. NaHCO3 we are supposed to add. But when it comes to the wasp sting, here alkaline solution is released. So then how can we relieve pain? By applying the vinegar. Okay, mild acid, that is to say vinegar. Whenever we are applying this, pain will be relieved. These are the applications of pH in our daily life. So next, we will go for the classification of acids. When it comes to the classification of acids, we have different streams. First is based upon the source from where we are getting the acids. So in that case, we have the organic acids and inorganic acids. Next, second one is based upon the strength. If we see strong acids, weak acids. And when it comes to the concentration based, so concentrated acids, and diluted acids. And when it comes to the basicity, regarding this later we will discuss. So first source based, from where we are extracting them. Based on that we have the organic acids and inorganic acids. When it comes to the inorganic acids, these are extracted under the earth crust in the form of minerals. Okay, these are exist as a minerals in the exist in under the earth crust in the form of minerals. From that we are going to extract them. According to Cbse NCERT textbook, we have HCl, H2SO4 and HNO3. Only these three were there as a inorganic acids for us. But when it comes to the organic acids, so organic acids, organic, what is the meaning of organic? These are occurred from the natural resource. So here example will be taken acetic acid. Not only acetic acid, its name is another name of this is common name is called as a vinegar. So not only this, citric acid from the lemon and tomato juice gives the oxalic acid, and milk gives the curd, gives the lactic acid. All these are coming from the natural resources. So that's why those will be known as the organic acids. So next, based upon the strength, if we see strong and weak acid. Strong is nothing but here when these are dissolved in water. Why? Dissolved in water. If more H plus ions are produced or less H plus ions are produced. So based on that, we used to say strong acids and weak acids. So strong acids will produce the more H plus ions. Weak acids will be produced less H plus ions. Another name of weak acids are organic acids. Another name of strong acids is inorganic acids. So now, when it comes to the concentrated solutions, so directly, suppose HCl if we are taking, directly if it takes HCl solution, it will be known as a concentrated. There is no water, there is no solvent. Solvent amount will be 0. Then those will be known as a concentrated solutions. When it comes to the diluted, HCl, suppose we are taking 10 ml and water we are taking as 100. Which is having the more quantity? Water is having more quantity and HCl is going to dissolve in the water. So then automatically H3 plus ions concentration will be increases. Then those will be known as a diluted acids. So now we will go for the basicity. So here first, before going to see here, earlier I said, so acid dissolving in the water. So here how it is dissociated? H plus and Cl minus. Cl minus in the water and H plus is going to combine with the water and forming as a H3O plus ion. Positively charged ion is released. So that's why the substances which are going to give the H plus ions are positively charged ion. Those will be known as acids. How far this H plus ions will be produced? Based on that, we used to say strong acids as well as the weak acids. Now, basicity of an acid. What is the meaning of basicity of an acid? So, number of H plus ions replaceable. Ionizable is nothing but number of replaceable H plus ions. How many number of replaceable H plus ions are present? Then those will be known as acids. Basicity we used to say. When it comes to HCl, how many are there? Only one is there. So that's why it will be called as a monobasic acid. And when it comes to the H2SO4, how many are there? Here, 2 H plus ions are producing. That's why dibasic we used to say. When it comes to the H3PO4, here 3 H plus ions are produced. That's why it will be called as a tribasic acid. See, in acetic acid, if we see, this represents the carbon. This white color represents the hydrogen. This red color represents the oxygen. So what is the formula we are supposed to write? CH3, C double bond O, OH. So here how many replaceable ions? Only one replaceable ion is there. So that's why it is monobasic. So when it comes to this sulfuric acid, here we have the possibility for this H ion and this H. So we used to say 2H plus ions can able to release. So that's why it is called as a dibasic acid. So when it comes to this, here how many? Here one, here one, here one. So 3. So tribasic acid we used to say. But when it comes to here, 1, 2. Only 2H plus ions can be released. So that's why it will be called as a dibasic acid. So now, physical properties of acids. First of all, if we taste the lemon, what is the flavor we used to see? See, if we taste this lemon, so we used to get the sour taste. So generally physical properties of acids means these will give the sour taste. And whenever we are going to dilute the acids, what is the procedure? Acid should not be added to the, water should not be added to the acid. Why? Here generally it is an exothermic reaction. What is the meaning of exothermic? Huge amount of heat energy release. Heat energy release, heat release. That's why it is calling as an exothermic. Thermic is nothing but heat. Exo is nothing but out. Heat energy is released out. So here we can able to do like this also. But particularly why we are going for acid addition to the water drop wise? Why? Because whenever we are going for the chemistry laboratory, we use most probably glassware. So whenever we are using glassware, so suddenly if we added water to the acid, more heat energy releases. More heat energy releases that leads to the breakage of glassware. To avoid that, we are supposed to add acid to the water. This is a way of dilution. So now, we will go for the next slide. And next, acids are corrosive in nature. See here, if we touch acids with our hand, it will be scalded. So bond. So from that we can say that acids are highly corrosive in nature. So just now I shown you one picture about the solubility of the water, solubility of acids in the water, corrosive in nature. So now we will discuss about the chemical properties of acids. So chemical properties of acids. So first point is about generally we used to see acids are in the condition of dilute or concentrated or hot concentrated. Three conditions for that. Dilute, concentrated or hot concentrated. These are the three conditions. So when it comes to the first example, I am taking HCl. If we take the HCl, it is going to react with the metals. Okay. First of all conditions, highly reactive metals reaction with the hydrochloric acid. So every time we used to see hydrogen gas liberation. Okay. So here in the first chapter also we have one activity, that is zinc granules dissolved in HCl. So when zinc granules, these are the granules, we are dissolving this in the HCl. Then hydrogen gas is released. How we can detect? Bubbles. By seeing the bubbles, we can able to see that hydrogen gas is liberated. And then, how that will be identified? If we bring this matchstick, burning matchstick near the mouth of the test tube, it will give pop-up sound. Along with the pop-up sound, flame will be put off. So from that, we can conclude that when metals reacting with the acids, hydrogen gas is releasing. So that hydrogen gas will be tested by using the burning matchstick, and while bringing burning matchstick near the mouth of the test tube, it is giving pop-up sound. Along with the put of the flame, we observe for the matchstick. In that way, we can conclude that metals are going to react with the acid and gives the when reacting with the HCl, releases hydrogen gas. So next, so when it comes to the least reactive metals like copper, when reacting with the concentrated, no reaction. When reacted with the dilute, we used to see no reaction. So when it comes to the hot concentrated, we used to get copper chloride. What is the color of copper chloride here? Copper chloride color is bluish green. Copper chloride color is bluish green. So next, silver and gold, these are the least reactive metals. That's why whatever may be the condition of acid, usually we used to see no reaction. And when it comes to the sulfuric acid, how this will be? See here, whenever we are taking concentrated or hot concentrated condition, metals are going to liberate sulfur dioxide along with the water molecule. Please, everybody note it down. This is very, very important. So normally, when acid is reacting with the metal, we are getting the hydrogen gas. But instead of that, here, when it comes to the concentrated and hot concentrated condition, we are seeing instead of hydrogen gas, we are seeing water molecule as well as a sulfur dioxide. So reason, what is the reason here? Sulfuric acid is a strong oxidizing agent. Sulfuric acid is a strong oxidizing agent. Sulfuric acid is a strong oxidizing agent. Because of that reason, we are getting instead of hydrogen water molecule, and sulfur dioxide itself reduces to the sulfuric acid itself reduces to the sulfur dioxide. So next, so when it comes to the silver and gold, no reaction. In the dilute condition, it is giving the no reaction. It is very, very important. And in hot concentrated condition, giving the hydrogen gas. And when it comes to the hot concentrated condition, we are getting the sulfur dioxide along with the water. So these three changes based upon the carbon, we are supposed to focus. And remaining all, whatever it may be, hot concentrated or hot concentrated, we are getting the water and sulfur dioxide due to the strong reducing nature and strong oxidizing nature of the sulfuric acid. And but when it comes to here, potassium with the dilute sulfuric acid, magnesium with the dilute sulfuric acid, sodium with the dilute sulfuric acid. Here we are not at all getting the water, but here we are getting the hydrogen gas. What is the reason? So here these metals are strong reducing agent. It's self-oxidizing, themselves oxidizing. So these will be act as a strong reducing agents. And next, reaction with the nitric acid. This is also repeatedly uh, given concept based questions. From here also we can expect more questions. So here, when it comes to this very dilute and dilute condition of nitric acid, we are getting the nitrous oxide. Very dilute and dilute condition, nitrous oxide. When it comes to the concentrated, we are seeing nitrogen dioxide. These variations you supposed to mark. Next, when it comes to the moderately reactive metals, dilute condition, nitrous oxide, very dilute condition, nitrous oxide. When it comes to the concentrated, once again we are getting nitrogen dioxide. But here one of the most important one, iron and aluminium when reacting with the nitric acid, giving the oxide layer. It is totally different. This supposed to be underlined. Next, if we go for the least reactive metals, in the very dilute condition, no reaction, but dilute and moderately concentrated. So wherever I am circling, please try to see carefully. Here we are getting nitrous oxide, and hot concentrated condition, here we are getting the nitrogen dioxide. And in the dilute condition, whatever it may be, we are taking silver and gold are going to give no reaction. So here earlier I said no, whatever I said. So magnesium, manganese, zinc, these are going to produce hydrogen. Why? So they are strong reducing agents. These metals are strong reducing agents. And when it comes to here, metals are liberating nitrous oxide and nitrogen dioxide. Why? Because nitric acid is a strong oxidizing agent. Okay. For all the metals, nitric acid is a strong oxidizing agent. Because of that reason, instead of hydrogen, we are getting nitrous oxide, nitrogen dioxide. But when it comes to these metals, these are highly reactive. That's why these will be acting as a strong reducing agents. Because of that reason, we are getting the hydrogen gas. Okay. So this is about the acids reaction with the metals. See here. Next, acids when reacts with the carbonates and bicarbonates. So acid I am taking HCl, carbonate, example I am taking sodium carbonate, and sodium hydrogen carbonate is for the sodium metal bicarbonates. So whenever we are taking sodium chloride is formed along with the water and carbon dioxide gas here. So how can we identify this? In the we used to see brisk effervescence with the colorless and odorless gas. So then, how can we identify this? This carbon dioxide, brisk effervescence is the indication for the carbon dioxide. Just a minute, children. So for this carbon dioxide, we used to see brisk effervescence, along with that colorless and odorless gas we used to see. So then how can we identify? This is a question. So here, whenever we added Slagle line, so here Slagle line we are taking, in that we passed carbon dioxide gas. These bubbles are nothing but carbon dioxide. So whenever these are passed, here we used to see these two mixed up together and gives the white precipitate. Milky white precipitate. Sometimes they used to give milky white precipitate. What is that? So here, insoluble milky white precipitate is formed. So that's why solution is not clear. But if we pass in the second condition, if we pass here, if we pass the limited, then we got like this. So here, if we pass the excess carbon dioxide, then we used to get calcium hydrogen carbonate. It will use the soluble clear solution. Calcium carbonate gives the clear solution. Instead, calcium carbonate turning to the calcium hydrogen carbonate, which is giving the clear solution. So here, see here. Here we have the bubbles here, some precipitations we used to see. But when it comes to here, we are getting the clear solution. Where if it is formed as a calcium hydrogen carbonate, it is there in the textbook beta. Instead of that, I taken here sodium carbonate and sodium hydrogen carbonate. So in both the cases, we are getting salt water along with the carbon dioxide. Okay. So this is about the metal carbonates reaction with the acids. So next, last one. See here, calcium carbonate. See here, given calcium carbonate reaction with the, it is about the neutralization. So we are getting the carbon dioxide. So here, this is about the neutralization. Here we used to say, sometimes here neutral salt we get. Here we are getting the acidic salt. So here any type of salt we will get. Generally we used to get the commonly salt. So next, reaction of acid with the base. When acid reacting with the base, we used to get salt along with the water. This is another problem. See here. Copper oxide when reacts with the water, we are getting the, earlier I said bluish green color. Copper chloride is formed along with the water molecule. Metal oxides reaction with the oxygen. Bluish green color, copper chloride is formed along with the water molecule. So with this, about the acids completed with the physical properties and chemical properties of acids. Along with that, we completed about the indicators. Okay. So still, if you have any doubts, you can please send a message, and or else you can come in contact and you can ask me. Okay. Thank you, children. Now I am going to complete wind up the session. Thank you, everyone. So now I am going to end the session. So whoever maybe want to utilize this service, please come to the competitive BBB channel. I am going to explain all this content. Whatever the doubts you have, those can be rectified here. I am using here slides. So in that you are going to get the clarity about the concept also. So once after completion of the chapter, I am going to explain what type of questions we may expect in the board paper also. Okay. Thank you, children. I am going to close the session.